how to develop plugins for Q-Sys, there were certain features I wasn't really able to figure out, usually because they just aren't very well documented. But today, I want to talk about the biggest one, audio processing. Along the way, I also want to talk about utilizing the code pin to make runtime code development much easier. I'll be using Visual Studio Code, along with the latest version of Q-Sys Designer, though any relatively recent version should work. Additionally, since audio processing doesn't work in emulate mode, I do have a Core 8 Flex in my desk setup, and this core has the scripting license on board, so I'll be able to test my plugin using that. Before I start to develop my plugins, I always like to create a container that has all of the components already laid out and wired that I plan to use for the plugin. This just makes it easier in my head to figure out what exactly all the connections I'm going to need are, what components they are, as well as what properties I'm going to need to adjust. So we'll go ahead and add in a container. What we're going to be doing for our plugin today is a gain followed by a high pass and a low pass filter with separate outputs. So we'll go ahead and create two outputs, and we'll open up our container here. We'll expand this out and move our outputs over to here. We'll start off by adding our gain and then add in our filters. So we'll put in a low pass and a high pass filter, and I'm actually going to switch the order of these just because that's what I'm used to. We'll reorganize these a little bit and wire that to there. We'll wire our gain to both filters, wire it to our inputs. We're also going to add some meters so we can see what audio is being processed. So we'll add in a level meter. We'll set this to a multi-channel with 3 channels. We'll go ahead and wire one to our input here, and one to our high output, and one to our low output. One thing I do want to mention that I've seen with the audio processing, for some reason in a plugin, if you attempt to connect an output to 3 different things, the third device never actually gets that audio. So if I turn this into a 4-channel meter and wired the gain to the meter as well, in the plugin, only 2 of those 3 items, the high pass filter, the low pass filter, and the meter, would ever actually get that audio. I'm not sure exactly why this is. A quick workaround would be to just use a matrix mixer. You can have as many outputs and inputs as you want to route your audio around, but we're just going to avoid that problem by not having a meter after our gain. So this container is pretty simple, shows off what we're trying to do here. We'll go ahead and put it off to the side. The next thing I want to do is to collect the properties of all these components so we know what we need to do in our plugin. So we'll select them, set the script access to script, and then we're going to create a control script. We'll place it in here, and then we're going to go to the QSC website. So now that we have our components in the container and accessible to a script, we're going to go to the QSC Q-Sys help under control scripting, extensions to Lua, and component. This get components example 1 gives us this nice little script. What it's going to do is give us the properties of every component that is accessible to this script in the design. You can see an example here. We have the name, we have the type, which is one thing we're going to need when creating our plugin, as well as the property name and value. So if we go back to here and we add in a control script, I've already copied that text over, so we'll paste it in here, save, and we can go ahead and emulate. So now you can see the properties of all of our components here. We have a gain of type gain, as well as a max gain, min gain, the ramp controls, stepper mode, the steps, etc. We have our low pass filter with a type of filter underscore low pass, a slope, type, count. We have the same thing for our high pass, as well as our meter. You'll notice that this is a type meter 2. So next thing we're going to need to do is to start up working on our plugin. In my GitHub here, I have a Q-Sys plugin template. This is what I use to just get me kickstarted with the plugin design. So what I'm going to do is take this file, I'll save it to my computer with a new name, and we'll get started writing our plugin. So now that our file is copied over, we're ready to go. We'll go ahead and start with a name, and we're just going to go with audio and the code pin. I'll give it a version of 0.1.0. ID, we're going to use a GUID for this. So you can use an online GUID generator. I'm just going to use Python and paste it here. Our description, we're going to put whatever we want. And then author, we're going to put our name. And we'll go ahead and get started on our properties. We're going to have two properties here, a maximum gain and a minimum gain. You'll notice with the actual gain control, if we disconnect here, these are properties that are available to it. So if we select here, we have the max gain and min gain. We're going to put a knob into our plugin that just allows us to modify that gain, and we're going to copy these max and min gain controls out to the plugin so they can be adjusted by the user when they load it. And now you can see we have our maximum and minimum gain here. We just follow the normal standard of plus 20 to minus 100 dB. So we'll continue on. We'll add in our pretty name and keep moving. The next thing we're going to look at is get controls and get control layout. And you'll notice in my template, I have this if enable code pin. Then we're going to insert this into here as well as into here. This is our code pin. Now the name itself doesn't actually matter. Code is just a de facto standard. The control type being text is probably the most critical thing here. That's in addition to just having the input pin set up and making sure there's something in it for the control layout. Even though you can see there's no position, the style is none, it won't show up. But if we don't have it here in this control layout, we won't get the pin. Having this text control type just allows us to bring in text into the plugin and install it. Whatever that text pin is wired to, the string that comes in on that pin will actually just get dropped into the end of our plugin here. So we're able to put a bunch of code for runtime usage into our plugin and modify it on the fly, since we can wire that code pin to a control script and we can modify a control script while the design is running. So now I'm going to go ahead and add in a couple of controls here. We're going to add the gain knob that I talked about earlier, as well as 3 meters so that we can actually see what the audio levels are. Now that I have those added in here, you can see for the gain knob, I set a min and max to the min and max gain from our properties. And the meters just have the normal minus 100 to 20. Everything's all set up, so we'll go ahead and add them into our layout as well. So now we've added these items to our control layout, and we can move on to our get pins. Now, get pins is the actual audio pins. These are the ones you would see up here, these circular ones, whereas the control pins would come in under the get controls. So we'll go ahead and start by creating our pins. These are fairly simple. We just need to give them a name. In this case, we're going to start with input. This is our audio input, and a direction. And the direction is going to be either input or output, and it's all lowercase. So we start with that, and we'll go ahead and create our 2 outputs. So now that our 3 pins are created, we're going to go ahead and get our components. These need 2 things at a minimum, but we're going to have 3. We'll start with a name, and I usually like to start these with an underscore. The type is going to be what we saw in the control script earlier, so for this one it's just a lowercase gain, and then we're also going to add some properties. So now I finished adding in my gain with the properties, including the maximum and minimum gain we set earlier from our plugin properties. our low pass and high pass filters, as well as our meter. Now you may notice that some of these things like the multi-channel types seem possibly a little bit arbitrary. Fortunately, using that properties script we had earlier, you can see the multi-channel type here is 3 and it's 1 here. And you can use that script just to figure out what the value is. That's one of the reasons I like doing these containers, so I can understand what everything is supposed to be set up as before I start to develop the plugin. So now what we're going to do is work on the wiring. And similar to the pins, this is quite simple. In fact, it's even easier. We just give it the name of the pin that it starts with, and then the name of the place that it goes. And the delimiter here between a component and a pin is just a space. So in this case, it's just _gain space input. This is the name of the pin. So if we take a look at our file here and we disconnect, you can see on the gain, it's just input. And this name here is what we defined in get pins earlier. So I'll go ahead and work on the rest of the wiring real quick. So our wiring's now been set up to match what we did in our design. Input goes to the gain and the meter. The gain's output goes to the input of the 2 filters. And then the output of each filter goes to the output pin as well as one of the meters. And so the only thing that's left is our runtime code. But as I mentioned earlier, we're going to work on that inside the design using the code pin. So we're over here back in our design. If I go over to plugins, you can see my plugin is right here. We'll go ahead, drop it in. We'll enable the code pin. And then we're also going to need another control script to feed our code into. We'll enable the code pin there. And then just to clean things up a little bit, we'll turn off the inputs and outputs. We'll go ahead and wire these together and then open up our script. Now I've already pre-written a script, so I'll go ahead and paste it in here. This is a fairly simple script. It's just a couple of event handlers as well as setting the frequency control in the 2 filters. So when the gain knob on the front panel of the plugin gets updated, we'll update the gain on the component inside, as well as when the value of the meters inside get updated, we'll update the front panel component for the meters. So now if we go ahead and open up our plugin, you can see our 3 meters in our gain knob, and we're going to get ready to test this. We'll go ahead and add in a pink noise source, wire that in, and get a pair of RTAs on our outputs. As I mentioned earlier, the emulate function doesn't work with audio processing, so we will have to load this design to a physical core. So I'll go ahead and do a save to core and run. And now that we're running, you can see our meters are starting to bounce around a little bit here. If we open up our pink noise generator and turn the volume up a little bit, it starts to get louder and quieter if we turn it down. If we modify our gain, you can see our output gets higher and then lower while our input stays the same. And if we go ahead and take a look at our RTAs, this is our high output. If I hover over, you can see that there. And this is our low output, which you can also see the name of there. Now, if we were to go into our control script, you can see that we have this attempt to index a nil value. I highly, highly recommend you ignore any errors you see in this script. What's happening is this is trying to run it as a script. All of those controls, properties, things like that aren't actually available to the script. They're only available in the plugin itself. So if we disconnect for a moment and turn on the show debug, and then go ahead and send it to the core again, you can see our debug messages here. So any errors we get here will be totally valid, but ones that show up in the script like this are ones that you don't have to worry about. Now, there are a few different things we could have done differently in this plugin. Obviously, changing the gain in the actual component or the maximum and minimum gain in its properties isn't really necessary since we're limiting it in the knob itself. But what I'm actually going to do is change this to be -100 and +20. And before I save this, we're going to go back to our design, disconnect, I'm going to go into the debug menu. If you don't have this available, you can look up online how to turn on the dev mode for Q-Sys, but we're going to enable auto load plugins, and that just prevents us from having to delete and re-add this plugin every single time we make a change in the actual Visual Studio Code file. So now that auto load is enabled, I can save this, and then let's go ahead and change our minimum gain. Let's make it 0. So now what this is going to do, our knob on the front end here can go down to -100 because we limited it that way, but the actual gain component inside is only going to be able to go down to 0. So we'll save to core and run. And with that running, let's go ahead and turn up our pink noise a little bit, and then bring up our gain. You can see it goes up, but as we start to go down, at this point, it's no longer doing anything. And that's because, as I said, the actual gain component inside this plugin is limited to 0 at the bottom. As mentioned before, you would actually want to limit this front knob instead of just the gain inside. Now, other things we can do, if we open up our control script here, you can see our high pass and our low pass frequency is both set to 1000. What I'm actually going to do is we'll take our high pass frequency and we'll set it to 6000. If I hit save changes, you can see our RTA has actually changed. This is one of the advantages of using the control script for this. If you need to make changes, you're trying to fix bugs, figure out what's going on with certain things, it's easy to be able to just make the change here instead of having to actually redeploy the design every single time you make a change. You can just keep going back and forth, see what's going on. If we adjust this down to 100 and save, that moves as well. So I hope you found this video to be helpful. There's a lot of different things you can do with the plugins, and being able to process audio is absolutely huge. One final note, you can't really write your own DSP algorithms in Q-Sys. You are limited to the ones that exist in the existing components. Fortunately, there are a lot of different components available, and by combining them together in creative ways, you can do a lot with them. So I hope you all enjoyed, and I'll see you in the next part.